All right, so I just want to remind you, how do you open a data file? You click here, you click open, and it goes through a lot of, it goes through your data file that you were last at. I have a lot of data files on my computer, as you can see. Now, I did mention it'll open a TST file, no problem. It'll open other files as well, but I'm using this Connecticut R1, this Wave 1, that 2013-2014 data file for the Connecticut traffic stop data. So I just double click this and it loads. It takes a while for it to load these big data files. So give yourself some time to load these files, but just a reminder, that's how you load a data file. There's probably 9 other ways to load a data file. So whatever way you get your data in there, I do not mind. And whatever data file you use for this assignment, I do not mind. So we just watched some videos on univariate graphing and calculating descriptive statistics, mean, standard deviation, so forth. How do we do that with Jamovi? It's super simple. First things first, though, I just want to focus us in on the fact that I have in my data set, if you're using the same one, I have filters on my subject age variable. Remember, last time I discovered there were impossible answers for subject age. So I just want you to know that I am going to use the subject age variable again to show you how to univariate graph and get those descriptive statistics. So how do I do that with this specific variable? I click Analyses, I click Exploration, I click Descriptives. I find my variable, which in this case is subject age. And you're gonna see all the same stuff. And let's look at what we got. First things first, just by clicking that button over, I get the mean, get the median, the minimum, the max. I'm not getting the standard deviation. I'm like, oh no, I got to do that by hand with over 594,000 observations. Oh God, no, I'm not doing that by hand. Nope, not at all. So I click this little arrow next to statistics. Just click that. And I choose the stats I want. We talked about mean, median, and mode. Let's go ahead and click those. I do not care about min, max. I do care about standard deviation. I do care about variance. Well, actually, I don't. If we know, we take the square root of 215, we're going to find 14.7. Let's keep it in standard deviation. All right. And then n and missing, I think those are good to have. Knowing that there are 594,658 observations is great with no missing data on this variable. I think that's pretty great to know. We still haven't done the univariate graphing. So I click this button next to plots. I click histogram. And you can see the histogram. Now, when we're looking at a histogram, one of the things we're always looking for, is there a bimodal distribution here? And when I'm looking at this, what that means is I'm looking for two normal curves that are kind of mating. I see two normal curves that are mating. Let me show you by clicking, I love this option, click the density option. And what you get is you're going to get a density curve that is applied on top of your histogram. And what I notice is it helps me see that yes, there are two normal curves that appear to be mating right here. There appears to be a lot, like one distribution centered around the age of 25 and one distribution centered around the age of 50. Conducting bivariate graphing is actually quite easy. But before you can do it, you have to add a new module. Look at the top right here. This plus sign, plus modules, you're going to add a new module. Plus, you're going to click Jamovi library. You're going to look for FlexPlot. They're not in alphabetical order, so you just have to read, but there we go, FlexPlot. You're going to click install. It will install, takes a few seconds depending on your internet connection. If you're at Regis, it might take you a couple minutes. The module is installed and you will see it shows up here under the word FlexPlot. Use FlexPlot. FlexPlot is great. click flex plot again, and you're going to let the computers do the thinking for you. Now, one of the questions I'm interested in is, does participants' race impact how long they're pulled over for? So right now, I just told FlexPlot to look at the relationship between all the subject race code variable and the intervention duration code. Now, intervention duration code, 1 means that the stop lasted 0 to 15 minutes, 2 is 15 to 30 minutes, and 3 is greater than 30 minutes. Now, before I look at the data, I want us to notice that there are options, plot type, which we won't use, fit options, which I will use. If you look here, it's using the median and the quartiles, has the measures of center and spread, and I'm just going to use the mean and the standard deviation. It's going to change. Another option is point options, which this just changes how the points look. There are no points in this data set, so I wouldn't worry about it. And paneling options, which we also don't have to worry about. Now, what you see here is an associations plot. When you're looking at the relationship between two categorical variables, and that's what we have here. We have category, which is subject race code. You can see all the racial codes right there presented on the x-axis. And we also have the intervention duration code listed as 1, 2, and 3. So this is a relationship between two categorical variables. What the association plot shows us is when a specific group is greater or less than expected. Now, the expectations would all fall at the 0 line. When I ran this analysis, I was curious if Black individuals were more likely to have longer traffic stops than other racial groups. And so I'm going to just what I'm doing is just looking at this area right here. And what we notice is that does appear to be the case. Black individuals are overrepresented in the 2 and 3 intervention duration codes. That means they are more likely than expected to have longer traffic stops, that 15 to 30 minute traffic stop or that greater than 30-minute traffic stop. Now you're like, well, where do the expected values come from? The expected values come from just the general base rates of intervention duration codes 1, 2, and 3. Right? But this is FlexPlot. It does this. It's super easy. It does the thinking for you. And that's great. This is a weird plot. This is not one that was talked about in the previous video. But it was a question. It was one that I had a question about. Now I want to run another FlexPlot in here. So FlexPlot. What do I want to examine? Well, in this case, I want to see, does the continuous variable of subject age, is that impacted by subject race code? So here, it's going to take it a while. It does take FlexPlot a while to run, but here we also have some other options we want to check. Nothing in plot type, but in fit options, I would like to make the same change to mean and standard deviation. So now you see the result of the FlexPlot, where it's looking at a categorical predictor and a continuous outcome measure. Now this is essentially a bar graph. Now it's not presented like your traditional bar graph, but it shows you the same information. But you're probably like, this looks like no bar graph I've ever seen. And that's because what you're seeing here, all these little black dots represent the actual raw data in the data file. So if I go ahead on my point options and change the percentage of dots to display to 0, those dots are going to go away. All right, now, in terms of my question, I'm not sure. I haven't run a statistical test. It looks like the age of Black individuals pulled over in Connecticut is a little bit less than the average age of other racial groups. Now, is it significant? Is it meaningful? We'll talk about that later in the semester. This is a scatter plot. I'm going to use the National Survey on Energy and the Environment. But ultimately, how do we create a scatter plot and FlexPlot? Very simply, FlexPlot. I'm going to choose my two variables of interest. One was being income. Does demographic income predict believing that global warming is a problem. What you see here is a scatter plot, and this is what they call a lowest line. It's not a linear line. Let's change that for us. So you click this little button next to fit options, change it to regression. It'll show you a linear line. It'll allow you to understand the correlation among these two variables. And what we see here is that that line is a flat line. There is no relationship between income and believing that global warming is a problem. Your homework is very simple. Create univariate graphs for two variables in a data set of your choosing. Make sure you get means and standard deviations. I'll show you that in a second. Use FlexPlot to create a bivariate graph of your choosing and save your output to PDF and turn that in. So if you look here, just real quickly, I've run these statistics. Here's my bivariate graph. Here are my univariate graphs with the descriptive statistics. My statistics do not have, I'm just going to simplify this to mean and standard deviation. And you can see that I have the statistics I need, and I have the two univariate graphs I need. I do not mind if you have the density on or off. That's up to you. But then I just simply, what you can see here, all exports. I'm going to go ahead and set it to my downloads. My graphing homework. I save that. I'm going to go find my graphing homework. And you'll see that it saved everything for me. And then that one easy step. That's all you have to do. If you give me something like this, that'll be great. If you have a problem with FlexPlot, do not worry. Okay? If you try it and it fails, you can get a little circle that keeps rolling and rolling and rolling, and you'll wait. You just let it sit for 10 minutes, you come back, and the circle's still going. Here's what I need you to do. Don't worry about it. Attach a Word document that says FlexPlot wouldn't work for your data file. Tell me what data file it was, and you will get credit for the assignment, and I will get a heads up about to look at your data file. That's all we need. But that is your homework for today. Should be easy, should be 100%. Good luck.